Continuing with the Section 7.2 lectures, we want to let f of t be the number of wildfires in the U.S. in thousands of fires at t years since 2000. So here are our years, here are our wildfires, and you can see I've already made a graph in Excel, which you will have to do as well for the project. There are videos for how to do that when you get to project. All right, so we're going to consider the scattergram. Is it better to use a linear, exponential, or quadratic function to model these data? Also something you'll have to do for your project. And rather obviously a quadratic is best because the points go back down and then back up. And the only graph that does that for us, that makes that kind of arch, is a quadratic graph. So the points go down and back up. Or if they went up and back down, if they made like a U shape or a hill shape. All right, so now we're going to verify that the model does well, fits these data well. So let me go to my calculator. I'm going to go to Stat, Edit. I'm going to clear out my old data. I'm going to type in my new 0, 1, 2, 3, 4, 7. Those are the years. And then go over here, and then I don't remember what these were. So let me make this smaller so I can see. 92.3, 84.1. All right, there they are. So we've got those in there. So you can see them. There they are. All right, so now I want to go to y equals. I'm going to clear out my old equation. I'm going to type in the new one they gave me, which was 2.14 t squared minus 15.03 t plus 93.58. So let's see if I can remember that. 2.14 x, that's this button right here, squared, that's that button right there, minus 15, so minus 15.03 x plus 93.58. There we go. All right, so I'm going to graph that, and I'm also going to graph the scattergram. So to do that, I go up, see how the cursor's blinking on plot 1, and I press enter, and that'll turn it on. So now it's going to graph a scattergram, that's the plot 1, and the curve, that's this 2.14x squared business. Now to make a normal window or a good window for this, I don't want to just press graph because I can't see what it's doing. It's off the screen somewhere. You can see that it's working up here, right? So I want to hit zoom 9. See it at the bottom of the screen, zoom 9? That's zoom stat. Because when you turn on plot 1, you're turning on a statistics plot. It's called a scatter plot, right? So you're turning on a stats plot. So hit zoom 9, and it'll make a window really nicely for you. And there's the curve. And the points are doing okay at coming close to the curve, so you can kind of copy that or draw a picture of it. That's what you'd be doing on your paper. And you'd be saying the points do a decent-ish job of coming close to the points. So let me write that out. There we go. So the quadratic model does a pretty decent job because it's coming close more or less to all the points. And you should draw a little picture for yourself and put it on there. Something like this of what your screen looks like. And if you want to give yourself scale, if you want to know, hey, what numbers were those that I'm graphing from? What's the left edge? What's the right edge? And so on. If you hit window, you can see it was about -1 on the one edge and about 8 on the high edge. That's the right side. So -1 to 8. And you could round it if you wanted. You could go -1 to 8 for yourself. And then go down here. Your Y min was about 57 and your Y max was about 102. I'm just rounding everything. And then you press graph, and there you go. Pretty much the same window. And you could say -1 over here, 8 over here, 57 over here, and whatever it was up there, 102 or something like that, or 120. I don't remember. 102. There you go. Okay. So we've got that. Graph's doing a decent job. So now we're going to find the vertex. Oops, that must be the next page. Find the vertex by hand, and what does it mean? So we have x equals -b over 2a. That would be, actually in this case it would not be x, it would be t, because our independent variable is t. So let me grab that. So t equals -b over 2a, which would be -15.03 divided by 2 times 2.14. Okay, so that's positive 15.03. That's pretty obvious on the numerator. The denominator well, I can tell what it is just by looking at it, but if you want to quit and do 2 times 2.14, you get 4.28. Now you take your calculator and you divide. 15.03 divided by 4.28. And you get 3.5116 or 117. $3.512. How about that? We'll just round it to 3 decimal places. Okay, so there's our t value. Now the y value is f of t. So I want f of 3.512. So that would be negative, or no, positive. That'd be 2.14 times that number squared. All right, 2.14 times 3.512 squared minus 15.03 times 3.512, and then I don't remember the last number, plus 93.58, plus 93.58, and then I'll just make my calculator find that. So go back here, clear. So I want 2.14 times, oops, there we go, times 3.512 squared minus 15.03 times 3.512 plus 93.58. And you get 67.1890, right? 1897 would be 67, my bad. 67.19. There it is, 67.19. All right, so there's the y for it. Okay, so the vertex is those two numbers put together. Okay, so we will have 3.512. Oops, I'm having issues there. There we go. I must have my caps lock on. It's driving me nuts. All right, vertex. There we go. Colon. All right. 3.512, comma, 67.190, technically, because it rounded. All right, so there's our final result there. Now we have to explain what it means. So this is about the number of wildfires. So there were the least number of wildfires. You got to explain that it's the minimum or the maximum, right? So it was the lowest number of wildfires. You have to say that word. Or if it was the maximum, it would be the highest number, right? So this was the lowest number. Remember your graph. You're finding this point down here at the bottom. So there were the lowest number of wildfires. And in 1993, wasn't 1990 our starter year? Oops, 2000 was our starter year, sorry. 2003. With only 67.19 thousand, which if you want to think about it would be 67,190, more or less, right? There we go. All right, we're done with that problem. Now we're going to verify what we just found with our calculators, with a graph. So let's go here. And I go to the graph, and I see I have these dots in there, and I don't really need them anymore. So I'm going to go to the y equals. I'm going to go up and turn plot 1 off, because it's just not necessary. I mean, you could leave them on if you want, but it's just kind of messy. And what I want is I want the calculator to find that bottom of that graph right there. So I'm going to go to second calc. I'm going to pick number 3 because it's a minimum that I'm trying to find on this one. Now I need to move the blinky, right, the blinky cursor. I want to move it to the left. So you got to move it over here to the left, somewhere to the left of that lowest point, and press enter. Now it wants the right bound, so I'm going to move it somewhere over to the right. So it has to be, so it's to the right of that lowest point, enter. Guess, I'm just going to press enter. It's fine. And there we go, 3.512, 67.1897, so 67.19. I'm going to take a picture of that. You would be drawing a quick sketch of it on your paper, because that's how you verify that you did this. And that's it. That's how to find the minimum with your calculator. That's everything we needed. And you would label this just like here, right? You'd point to that point and label it with those coordinates. All right, we're all done with section 7.2. I'll see you back here for 7.3, part 1.